Welcome to EPG Pathshala. In our previous modules, we discussed what is statistics and its type, data types, and measurement scale. In this module, we will discuss diagrammatic and graphical representation of data. As you know, data are collected from various resources in raw form. After collecting data and editing the data, we require to represent the data. As we know that classification and tabulation of the data can be used to represent it, but sometimes it is difficult to understand by a layman person. For that, we require diagrammatic and graphical representation of data. In this module, we will see what is frequency distribution and its type. After that, we will cover one-dimensional graphical representation. Statistics is a science that is based on description of data, either numerical or diagrammatic or other way. This science is used to extract information from the data based on the objective, as data can be in quantitative form as well as in qualitative form. Data are collected from the various resources of study and they are available in raw form. So, after collecting and editing the data, the next stage is to organize the data. Classification and tabulation of the data are among the most important tools for the precise, clear, and comprehensive representation of data. Due to technicality involves in these forms, it may not interesting for a common person to be able to understand the things in a simple manner. Another way to represent the data is through diagrammatic and graphs that represents the data into attractive manner that appeal more to the mind of spectator due to attractiveness, fascination, and impressiveness than the other methods. The best part of diagrammatic representation method is that even a layman person can understand this without any previous knowledge of statistics. Another important feature of the diagrammatic and graphical representation are that it saves lot of time, as these are easy to build up and one can draw meaningful inferences from them easily. As these methods are also able to present that information that might be lost amid the details of classification and tabulation of data. These methods also facilitate the person for comparing the value of two or more sets of data. Graphs and charts are used to clarify a complex problem and reveal the hidden facts that are not clear from the tabular form. Hence, graphs and diagrams are important not only for the representation of the data as well as for visual comparison of two or more data sets. Now, what is frequency distribution? In English language, frequency means the rate of occurrences of something in a repetitive manner in a particular time interval or time frame. Statistics is concerned with the extraction of information from the numbers collected in a raw form from the study. In practical life, variables are used to represent these numbers in case of quantitative data, like in a study of sales of luxury car in a particular region in a year. One can consider the sale of a car in a day as a variable and note down the sale of a car in a day by a variable denoted as x subscript I, where I takes value from 1 to 365 that represents the days in a year. Here the value x1, x subscript 2, so on x subscript 365 represents the sales of a car in the first day of a year or financial year, and similarly second day of the year and so on. the values of x1, x2, so on, x365 are known as the values of the variable. Frequency of a value of the variable means the number of times a small same value represents in the whole data set. For example, if we assume that the number of sales of a car are 2 units on 10th day, 3 units on 20th day, 2 units on the 45th day, 4 units on the 70th day of the year, and so on. Here 2 units appear 2 times, 3 and 4 units appear single time from the available information. So from the available information, the frequency of sale of 2 cars per day is 2 and other has only 1. With an increase in the available information, one can construct frequency table that represents the repetition of the values in the data set. So in table 1, you can see that on the left hand side we have observations and on the right hand side we have correspondingly frequency value. For example, let us consider the observations of sale of the car in the month of February, and these are the figures. So from the table 1 we observe that 7 days 2 units of cars are sold, for 6 days 3 cars are sold, and so on. Hence one can form the frequency table by counting the same observation in the data set. That means frequency of a value of a variable is the number of times it occurs in a given series of observations. Now there are two forms of frequency distributions: ungrouped frequency distributions and grouped frequency distribution. Ungrouped frequency distribution, in which table shows the frequency of the value in the data set on individual basis. In ungrouped frequency distribution, table shows the frequency of the values in the data set on individual basis. Table number 2 is an example of ungrouped frequency distribution, as the first column in the table represents the observation and second column shows correspondingly frequency. Now from table 2 you can see that on the left hand side we have IQ score of the students and correspondingly frequency on the right hand side. Now come to the group frequency distribution. In this method, the values of the variables are shown in the group or interval. Table number 3, observations are used to represent them in group frequency distribution, as the smallest observation in the data set is 35 and maximum value is 94. In table number 4, we consider width of the interval as 10 and lowest class value as 30, and so on till we cover the maximum value in the data set. So in table 3 we have 30 IQ scores of students, and in table 4 we construct group frequency distributions of the data set. So on the left hand side we have intervals, that is 30 to 40, 40 to 50, 50 60, 60 70, and corresponding 90 to 100. And on the right hand side we have corresponding frequency value. That means that we have two students IQ that lies between 30 to 40, and similarly 50 to 60 interval we have 3 frequency. That means we have 3 students who has IQs that lies between 50 to 60, and so on. Now on the comparison of table 2 and table 4, one can see that group frequency distribution visualize the important characteristics of the data in a simple and understandable manner about the tendency of IQ score of students over ungrouped frequency distributions. Now there are some steps for the construction of group frequency distributions. Many techniques are used for the formation of the group frequency distribution. There are few points that must be kept in mind while preparing a group frequency table. First is class type. one should define class type in a very clear manner. It should be exhaustive and mutually exclusive, so that variables value must be assigned to only one class in the table. Now next is class interval. It means how many intervals should be formed for the available data. Number of intervals depend on the things like number of observations in the data, its magnitude value, level of precision, and further analysis of the data. The most common formula that is used for the determination of the interval in group frequency distribution is Sturge rule, that is represented in the form k is equal to 1 plus 3.322 log base 10 capital N, where k is the number of classes and capital N is the total number of observations in the data. Now it is important to determine width of the class interval. So width of the interval means the difference between the lower limit and upper limit of the interval. The width of the interval is defined through the formula that is given here, that is h is equal to range over number of classes, where range represents the difference between highest value in the observation in the data set minus lowest value in the data set, where h denotes the width of the class interval and range is defined as difference between the highest and lowest value of the data set. Now come to class limits method. There are different methods that are used for the classification of the data set on the basis of class interval. The limit consists of two numbers that are used for the purpose of tallying observations into various classes. There are two different methods for the classification of data on the basis of class intervals. These are inclusive method and exclusive method. First is inclusive method. In inclusive method, the upper limit of a class interval is considered in the interval itself and it is not related with the next class. For example, the class, if we consider the class limits as 0 to 4, 5 to 9, 10 to 14, 15 to 19 and so on. Now second is exclusive method. In this method, the data are classified into class interval of such type that upper limit of one interval is the lower limit of next succeeding class interval. For example, in exclusive method, the class limit should be of such type that is 0 to 5, 5 to 10, 10 to 15 and so on. So one can easily observe that in exclusive method we do not consider that if we consider 0 to 5 as our limit, then we can't take 4 on the next interval. This is the major drawback of inclusive method, that let us suppose if you want to put the value of 4.5, then in inclusive method we can't consider it, but in exclusive method it can be considered. Mid value or midpoint. Mid value is the calculated by taking the sum of upper and lower limit of the interval and divide that sum by 2. This value is used as a representative value of the class interval and it is used for evaluation of mean, median, mode and higher movements of the data. Now come to cumulative frequency distribution. Frequency distributions count the occurrence of the same value in the data, but sometimes one is interested in the number of observations that are small or greater than a given value. In such type of situation, one has to calculate the accumulated frequency less than or greater than some specified value. This accumulated value is known as cumulative frequency distribution. Now, from the above table, you can see that less than or more than frequency table is given on the right hand side of the table. Now, the procedure is how to calculate the less type cumulative frequency and more than frequency cumulative frequency. For that, we can see that in the class interval 30 to 40 we have frequency value 2, and on the next interval we have frequency value 4, that is for interval 40 to 50. For less than cumulative frequency, we add the frequency of the preceding class in the class interval, that is 40 to 50, and for more than cumulative frequency we subtract the frequency of the previous class, that is 2, from 30. So we get 28. Now, use of diagrammatic and graphical presentation of the data. Diagrammatic and graphical presentation of the data are useful in practice due to following reasons. These are: the information that we acquire from the graphical and diagrammatic representation of the data is easy to understand even for a layman person due to its simplicity. As people are more interested in graphical representation of facts than just numbers due to eye-catching effect of diagram or pictures. As graphs and pictures can simplify the complexity of the data that cannot be easily be understood with the figures. With the graphical presentation, one can easily compare the statistical data relating to different time and place to bring out the hidden facts and relationship among the statistical value. There are some limitations of diagrammatic and graphical presentations, like they do not show the detail behind the numbers that can only be shown from the table in a better way. As only a single diagram or graph has not a great importance, rather than it is used for comparison purpose with other diagrams or graphs. So there are some differences between diagrams and graph. So there are some few rules, based on them one can differentiate between graphs and diagram, but these rules are not standard for all. So there is a scope of changes in these rules among different persons, but we will discuss few of them that are considered common for all. These rules are: diagram are basically plotted on the white paper graph, while graphs are plotted on a paper called graph paper. Due to its features, like to study the mathematical or numerical relationship between variables. In diagrammatic, precise relationship among variables are not discussed. In diagram, different tools like bars, rectangles, circles are used to present the information in the data, whereas in graph, different tools like lines, dot, etc. are used to present the data. Diagrams only give approximate information regarding the data, as this information will not be used further for analysis purpose. On the other hand, graphs give more precise, accurate information about the data, and they are used for further analysis purpose. Diagrams are used for the presentation of the categorical and geographical information in the data. On the other hand, graphs are used for the presentation of the time series and frequency distribution. Diagrams are more eye-catching than graphs. Also, diagrams are used for the understanding of the layman person, but graphs are used by experts from the field for the further analysis of the information. Graphs are easier to build than comparative to the diagram. There are few points based on which one keep in mind while constructing the diagrams. These are: diagrams give only a pictorial representation of the quantitative data for rough guesses. It can only be used for homogeneous data. It is not reliable to make further inference about the data. While constructing diagrams, there are some general rules that should be followed. These are: an appropriate diagram can only present the data in a better way. So, it is essential to choose the right diagram from the data that need expertise as well as knowledge. It may be possible that due to inappropriate selection of diagram, the interpretation might be wrong. That can lead to unbearable results. So, it is also important that a diagram should have an appropriate title corresponding to the nature of the data. With an appropriate title, a person can understand the main idea in the diagram. It should be constructed in such a way that it portrays all relevant information within an allotted space. So, it should be appropriate in terms of size and consistent in terms of dimensions. It should be neat, clean, and footnotes and proper indexing that will attract the interest of the common man. Types of diagram. There are many types of diagram based on its dimensionality. These are one-dimensional diagram, two-dimensional diagram, pie chart, three-dimensional diagrams. As each type of diagram is used for specific type of data, that is for complex data, one need more dimension to see the impact of one factor on the other. Hence, the choice of the type of the data depends on the nature of the data. Now come to one-dimensional diagram. These type of diagram use only one dimension, that is only length of bars and lines are taken into account. So, these diagrams are known as one-dimensional diagram. Bars may be vertical or horizontal. Vertical bars are mostly used to represent growth or decline rate of the variable under study, while horizontal bars are used to represent the data of attribute. There are few points that should be kept in mind while using bars. Bars should be constructed within an allotted space and of uniform shape and size. Scale should be chosen according to the magnitude of the observation. Bars must have the same baseline for a given data. It is better to represent the value at the top of the bar for the convenience of the reader. Bars should be arranged from the left to right in order of magnitude for consistency. The following data gives the approximate average yield of rice in kg per acre in different states of a country during 2000 and 2001. So, in the table you can see in the above row we have different states like Punjab, Himachal Pradesh, Gujarat, West Bengal, and yield in kg per acre is represented in the second row. So in Punjab we have figure 640, in Himachal Pradesh we have figure 520, Gujarat 320, and in West Bengal that is 1090. So from the above figure one can observe that the above diagram satisfy all the condition, as we can see the bars are of same width in each state, and one can easily see that which bar represent for which state, and footnotes and title that add importance for understanding. Now we come to the conclusion part of this module. As we have seen that we covered frequency distribution, cumulative frequency distributions, grouped ungrouped frequency distributions, one-dimensional diagram. So we use these methods to present our data that helps to understand our data set in a more appropriate manner. So thank you.